Hello everybody! In this video we're going to write a function that's a variation on the Dirichlet function that we were working on in the previous couple of videos. So what's the idea for this one is as input we're going to take a and s, so you should be familiar. A is our starting number, s is our step size. This is a new parameter n, and we want to return a vector v, and what we want to return is the first n primes in the arithmetic progression that goes a plus s, a plus 2s, a plus 3s, and so on. So the way we're going to do this is we're going to start by initializing v to be the empty vector. So this should be familiar by now. And I'm going to index, so notice here we add 1s, 2s, 3s. So I'm going to index that number in front that we're multiplying s by with the variable k. So k starts at 0 because here we're adding 0s, then 1. And I'm going to say while the length of v is less than n. Now notice here that I've done strictly less than. So think about why I didn't do less than or equal to, and I'll talk about it when we finished writing the function. We're going to check. So if is prime of a plus step size s times k, then we're going to take v, and again this is a very common pattern. Keep v the same, just tack on a plus s times k, so that's the prime number. So we're saying if this is a prime number, add it to our vector. We don't need an else statement because if it's not prime, then we don't need to do anything. Then we're going to update k, so k is going to go to k plus 1, and then we can end the while loop. So again, let's do a recap. We're saying while the length of v is strictly less than n, if a plus s times k is prime, add it to the vector. Otherwise, k is equal to k plus 1. Now imagine that we have a vector of length n minus 1. So we've found n minus 1 primes. Then we go back and we say while length of v is, so n minus 1 is definitely less than n. Then we go back into the for loop, and when we find another prime, it gets updated to length n. The reason we don't want less than or equal to here is that if it's equal to n, then while, so length of n is equal to n, then we go back in, and when we find another prime, it's going to add it, and we're going to have length n plus 1. So less than n is going to give us a vector of length exactly n. And this k equals k plus 1, this is moving us through the sequence so that we can just kind of keep going. So we're saying first go a, then a plus s, then a plus 2s, so this is s times k, and so on. So let's run it and see what happens. So let's save, go back to our editor. Let's say Dirichlet, let's do 8, 7. Let's find the first 10 primes. Oops, and I must have spelled it. Oh, Dirichlet 2, that's my bad. There we go. So we can see here, if we do like length of answer, it found exactly 10 primes. Notice we can find 100 primes very quickly. And even 1,000 we should be able to do pretty quickly. So very fast and efficient code. I think this is a good place to stop. So just a short video showing you one other kind of variant on the function that we were writing earlier. So thank you so much for watching, and I will see you in the next video.